The next characteristic we can determine about a polynomial based on its degree and its leading coefficient is the end behavior. This leads us into the leading coefficient test. The leading coefficient test says that the end behavior of a polynomial, what happens to the graph as you approach positive or negative infinity, going to the left and the right, can be determined by the leading term, a sub n times x to the n. This can be summed up in a chart that I'm going to draw here, where I have 4 possible cases. A degree being odd, the degree being even. It's 2 cases, and there's a subcase. We have the degree being odd, but with a positive leading coefficient, the degree being odd with a negative coefficient. Then the third case, the degree being even with a positive leading coefficient, and then the degree being even with a negative leading coefficient. Those are the 4 cases, and they look like this. If a function has a degree that is odd with a positive leading coefficient, then that function falls going to the left and rises going to the right. Again, this only tells us what happens at positive or negative infinity, so it doesn't tell us what happens in between. If we have an odd degree with a negative leading coefficient, then it rises going to the left and falls going to the right. If they're odd, if the degree is odd, then the function goes in opposite directions. Okay, at the ends. Note that. Then, if the degree is even, but the leading coefficient is positive, then it rises to the left and rises to the right. 4th case. If the degree is even, but the leading coefficient is negative, then it falls to the left and falls to the right. These should remind you of the behavior of lines with a positive slope, a negative slope, and quadratic with a positive a value and a negative a value. Now let's use this to determine and describe the end behavior of the following graphs by drawing arrows and telling which side rises or falls. First thing I want to notice, on f of x equals 3x to the 4th minus 2x cubed plus 3, the degree here is odd. Oh, nope, the highest is 4. The degree is even. And we have a positive leading coefficient of 3. So 3x to the 4th determines all of that. Because it's even, with a positive leading coefficient, that means that it rises to the left and it rises to the right. So, rises to the left and rises to the right. Second function, f of x equals x to the 5th plus 1/4 x plus 1. Our leading term is the x to the 5th. So this is odd with a positive leading coefficient. Odd with a positive leading coefficient means that it falls to the left and rises to the right. So now let's just write that. Falls to the left, rises to the right. Next function we have, f of x equals negative 5x cubed minus x squared plus 4x plus 2. Our leading term is this negative 5x cubed. That is odd, but with a negative leading coefficient. That tells us that it is going to rise to the left and fall to the right. Rise to the left, fall to the right. And our last function, f of x equals negative 4x cubed, parentheses, x minus 1 parentheses squared, and times parentheses, x plus 5, close parentheses. This one is written in a different fashion, but we can deduce what the leading term would be by observing that this is an x cubed, This will be an x times an x. This is an x squared. So x cubed, x squared. And this last one would just have the highest exponent will be an x. Adding those up, we get 6. So this is a degree 6, which is even. Now for the leading coefficient, we want to notice that we have a -4. Do this in a different color. I have a -4. This is a +1 and a +1. And so because that middle factor is squared, this would be -4 times 1 times 1. We are at twice times 1 for that last. So that would be a leading coefficient of -4. So this is negative. Even degree. Negative leading coefficient means that it falls to the left and to the right. Falls to the left, falls to the right.